Hello and welcome student to another episode in our C# fundamental course. I am looking forward to another interesting topic, but before we dive into today's lecture, into today's topic, I would like to point out an important thing regarding our exercises, regarding our homework. Last week we discussed stack, heap, and references. Particularly references are important for today's lesson and for the upcoming weeks. So I gave you a homework, an exercise to work on. I hope you can all remember. You can find it in our GitHub repository. Here it is. And this was the exercise. I called it the garage exercise because you had to maintain an array of parking spaces where one could park an electric vehicle, for instance. So if you haven't done this homework, definitely check it out. It's really important that you understand this exercise. Now, the reason why I'm getting into this is I added you recently, an hour ago or something like this, a sample solution. You had the whole week to work on this exercise, and now I'm giving you a sample solution. So if you are stuck somewhere in this exercise, if you are not sure if you took the correct approach, you can either ask me, of course, but this sample solution should help you doing some self-study. So please take a look at this sample solution. If you haven't done this homework yet, if you haven't worked on this example, completed it, then please stop the video here. Try to use the sample solution to overcome any problems. It's really important that you have a solid understanding about references and particularly also null references before we can dive into today's lesson. Very well. With that said, I would like to dive right into today's topic. And today's topic will be the first advanced data structure that we will cover in this course. So far, I showed you records, I showed you classes, we had some basic data types, and we also took a look at arrays. But today, we are going to take a look at queues. You all know what a queue is, right? You know it from the cinema, you know it from standing in a queue in front of a restaurant or any other kind of booth where you can buy something. A queue works based on the FIFO principle, first in, first out. So if you enter the queue, then you will be the first one to leave it on the other side. That is different from, for instance, a stack. If you have multiple things on top of it, if you put something on top, it's the last in, and it will be the first one that is taken off the stack. So that is the LIFO principle. But we are here with the queue, and that is the first in, first out principle. So let me try to visualize that. I'm using Draw.io here. I will probably write not a lot of code today, so bear with me. We are going to do some conceptual talk here. So let's take a look and let's take this rectangle. Let's say this is somebody who enters the queue. So this somebody, let's make it a little bit smaller, something like this. So this somebody entered the queue here. So if somebody else is coming into this queue, this somebody else is standing here, and this somebody else is now pointing to the element which is in front of the queue. If somebody else wants to enter the queue again, entering happens from the right side as drawn here, and we reach this element, and this is the one who will leave the queue right in front of us, and so far it goes on and on. So elements coming here from the right, something like this, and then we have another link here, this element, we can link it to this element, and here you see this is the first element in the queue. So this will be the next one who leaves the queue, and this is the last element in the queue. If we add something, we always add from the right. If we take something out of the queue, we always take it out here, the first one to the left. So this is a conceptual picture in your mind how queues work. In practice, there are a lot of queues, a lot of applications for queues in IT. Essentially, it's wherever you use a queue in real life. If you have a digital analogy to that, you can always use the queue data structure. So let's try to find out what's going to happen if somebody leaves the queue. The first one here, this one, is now taken out of the queue, and we remove that relationship. So this is now an element that was taken out of the queue, and this is the new first value. So this is the first one who is going to leave the queue. This is now processed, maybe then forgotten, deleted because we don't need it anymore. That is fine. So if somebody else wants to enter the queue, then this element is no longer the last element in the queue. Instead, a new element comes here from the right, and we have a connection here, and this one will now be the last element. So you see, that is a very important concept. So now let's think about what's going to happen if we remove some of these elements. So the first one is no longer the first one. We forget this link. We take this element, we process this element, we do something with it. At one point in time, we forget about it, and this will be our new first element. Now we repeat that. This one, again, will no longer be the first element. Let's delete it. Let's move it here to the right. Let's forget about this reference here. Let's process this element. This element will be gone, and this is the new first. And now it's getting very interesting, because what happens if we take out this element? Well, same thing happens. We take this one out. This is no longer the first element. We forget about this reference here. This one will be processed, so we forget about it, and suddenly we have only one element in the queue. So this one is now the first and the last at the same time. Okay? That is a very important thought. Please keep that in mind. So now we have one element in the queue. And what happens if even that element is processed, taken out of the queue? Now we forget about that because it has been processed. And where is our first and last? The answer is first is now null and last is also null. Can you remember null pointers, null references from last time? Null means essentially no value. So you see, with first and last, we can apply the things that we learned last time. We can use references to keep track of our first element in the queue. Then we link all the elements to each other, and then we have a last element where we have another reference. So let's take a look at a little bit of code. I will not write the entire sample because this will be, again, your homework. But let's take a look at a little bit of code so you understand the basics, and then you can finish it on your own. Here I am in my console. So what I'm going to do now is I'm going to create a new application. By the way, did you see the following thing happen? List runtimes. See, .NET 8 has come out, only a few days. So this is something that you should definitely do after watching this video. Upgrade to the final version of .NET 8. To no longer use the release candidate or older versions of .NET. Now we can use .NET 8, and you should start using it immediately. At least I will do that. So let's create a new app. .NET New Console. Once we get this app, let's open it up in Visual Studio Code. That should only take a few seconds. Here we are. Let's make the font a little bit larger so you can follow along. This looks good. Let's go into program and let's think about how we can implement the queue. First, we need to think about what these elements, the rectangles from my drawing before, what they are. Essentially, they are classes. So let's create a class and let's call it customer in queue. Let's assume that we are maintaining a list of customers standing in front of a restaurant. This is exactly the homework that I have for you. Now let's implement this class. We will define here public string name. Let's assume that each customer has a name. Let's say we have a public string phone number. So we can call the customer if something happens or the customer doesn't show up. And at the end, we are also creating a constructor. And in this case, GitHub Copilot is suggesting this constructor, and it looks nice. However, .NET 8 came out, so we can take a look at a brand new feature in .NET 8. You see, that is the old way of doing things, and Visual Studio Code is immediately suggesting that I can do something pretty neat. I can use the new primary constructor feature. Let me teach you about that. I can simply press enter and see what's going to happen. A lot of code just disappears. Let me make it slower for you. Remember, the constructor gets two parameters, and then the constructor assigns these values inside of the constructor's body. Now, if I switch to primary constructors, I can move the list of parameters for the constructors into the class declaration. You see? Class, class name, and then we have the parameters of the constructor. And then immediately when declaring here our properties, we can assign the value from the constructor parameter immediately here. So that saves us a few lines of code. If you have larger classes, it saves you more code. So from now on, I'm going to regularly use primary constructors in classes, but keep in mind, this is a .NET 8 feature. If you have to work with earlier versions of .NET, this does not work. However, let's get back to our queue. Can you remember what I drew for you a few minutes ago? We had a customer, we had another customer, something like this, and then we had a connection between these two customers. And this is exactly missing in our class. What we need to add is we need to add a link from one customer to the other, so each customer knows who is standing in front of her. It's like taking my arm and putting it on the shoulder of the customer that is standing right in front of me, so I know who is in front in the line. And that is done using a references that we discussed last time in very much detail. So we can say public customer in queue. This is an optional reference because if I am the last one in the queue or the first one, depending from which side you are counting, there is nobody in front of me. So it has to be optional. And let's say this is the next, this one, set something like this. So this is now an important one. We have a link from each customer to the next customer in the queue. Now you have to understand that next can mean two things here. We can start from the customer who entered the queue last and see the one who is standing in front of the queue, in the queue as the next one. But we can also take a look at the queue from the other side, and we can take a look at the customer who will be next one served, and the next customer is the one standing behind in the queue. So as developers, we have to have a mental image in our head. What next mean? Are we looking from the front to the back, or are we looking from the back to the front? It works both ways. You can implement it either in this way or you can implement it in that way. You can do it however you want, but you have to be clear. You have to be clear in your mind. You have to have a clear mental picture of what's going on. So this is the next pointer. And for now, next reference. For now, I will assume that the references work from the beginning of the queue, meaning the one who will the one who will leave next, to the end of the queue. So our queue will look like that. We have a customer. That is the customer who is the first one, according to the drawing that we had before. And then we will have the next customer and the next customer and the next customer. And this customer is the one who entered last. And my next pointer, as I will implement it, will point in this direction. Okay? So we will start with the first, and the next one is the second in line. The next one is the third in line. The next one is the fourth in line. And the last one doesn't have a next. So in this case, next is null. Good? I hope you could follow. So now we have to remember the first customer and optionally also the last customer. Do we need the last customer? Well, no. We can also take the first one and follow all next references, and at the end we will reach the last one. Is it useful to immediately know who the last one is? Yes, sometimes it's very useful, and therefore I will store both references, to the first and to the last. Let's see how we can do that. We can declare a variable. Let's call it customer in queue. Does it have to have a value? No, because if the queue is empty, there is no first customer. Sorry, first. Let's just call it first, okay? There is no first customer in this case. And guess what? We need a last one too. And now the data structure of our queue is perfectly fine. Now we are capable of maintaining a queue of customers. This is what we are going to do here. Now let's think about how it happens. What do we have to do if we would like to... First, let me turn off GitHub Copilot because it's spoilering the information that I want to give you now. What do we have to do in order to add a customer? In this case, it's the first customer. Let's think about it. We can say, okay, we have a var new customer. This will be the new one entering the queue. And this will be the customer in queue. And that is I don't know, that is John. And his phone number is 1234556. I don't know. It doesn't matter. Okay, sorry, I forgot the new keyword here. Now we have a new customer, but this customer should now be the first in line. But because we only have a single customer in the queue, it will also be the last one. So what we can say is first equals new customer. We have a reference here, and last equals new customer. So this is what we can do. Let's visualize the queue as it is now. This is our John. This is John. And John is referenced by the first reference. And John is also referenced by the last reference. This is how our queue looks like. Okay, now we can add new customers to the queue. Now let's think about what happens if we want to add a second customer. So the new customer in this case will now be new customer in queue, Jane. And Jane has a different phone number. Phone number doesn't really matter. Now, what we want to do is we want to add another customer at the end of the queue. Now, let's think about, will the first reference change? No, obviously not. This will still be John. Will the last reference change? Yes, obviously it will. Will John change? Yes, because he now has a next customer. So what we have to do is essentially take the last customer, last, and set the next reference to the new customer. So now John is referencing Jane because she is standing right behind him in the queue. And additionally, we have to say last equals also new customer. So now we have a working queue again. Let's visualize the status of the queue as it is now. This is John. He is referenced by the first reference. Now the new person in the queue is Jane. Here you see that we changed the next pointer of John so that this next pointer is now pointing to Jane. That is exactly how the queue should work. And additionally, here we change the last pointer and we will point the last pointer to Jane. And that's now exactly as this whole thing goes on and on and on. If we add new customers, new customers, new customers, we always perform these two operations. We change the last.next reference and we change the last reference. Good. I like that. I think we should take a look at the opposite operation. Now let's take a customer out of the queue. Take customer out of the queue. Can you remember I told you that queues work based on the FIFO principle, first in, first out. The first one who entered the queue will be the first one leaving the queue. So in our case, we will take John out. So let's think about what we have to do. Do we have to change the last reference? No, because at the end of the queue, nothing changes in our case. Do we have to change anything with Jane? No, because Jane does not have a reference to John. It's the other way around. John has a reference to Jane. Do we have to change the first reference? Yes, obviously, because we take the first customer out of the queue. So what we have to do is we have to say first equals to first.next. Understood? So we take the next customer in the queue, who is Jane, and we make the next customer in the queue the new customer. And what happens with John? Remember last week? The garbage collector will clean up. The garbage collector will go through all our memory, and because we have no longer any reference to John, he will simply disappear. Let's visualize what I just told you. We had John. I will now make it a little bit shorter. I will not write all the descriptions here. We have Jane, we have the next pointer, we have the first pointer, and we have the last pointer, as you can see it here. So now I will change the colors and indicate what's going to happen. Now, as you can see here, oh, that's the wrong one. We are here. We are going to say that the first pointer is no longer pointing to John. Instead, the first pointer points to wherever John's next pointer points to. So essentially, the first pointer is now this one. Now what happens with John? We have no reference pointing to John anymore. John has a reference pointing to somebody else, but no one remembers poor John. What happens with John? The garbage collector comes around and simply frees John. In practice, maybe we have processed John, we have done some calculations, whatever we want to do. John disappears, this reference disappears, and now our queue simply consists of Jane, and the first pointer points to Jane and the last pointer points to Jane. So we successfully removed one element out of the queue. And with that, we now have all the operations that a queue typically has. We can put someone in at the end, take someone out at the front, and maintain the references accordingly. Time to practice. Of course, I have an exercise for you, an exercise on which I want you to work here in school if you are in my class, and then of course at home to practice your skills working with references and implementing your first queue. You can find this example here in this folder, restaurant queue, and if we scroll down a little bit, you will see what you have to implement. Essentially, you're implementing a very simple queue that maintains customers who are waiting for being seated as a restaurant. Please read the specification of the homework. I will not read it for you. I added some implementation tips. I also added some visualization so you can hopefully remember what you just learned and understand what you have to do. I know that some of you have already more experience in software development, so therefore I didn't just add the basic requirements, but I also added 2 extra requirements. The first extra requirement is requiring you to save the queue to a file and being able to load the queue from the file again. And the second advanced requirement is a pretty hard one, at least for your level of experience. In this case, we are implementing an extra function where a customer who is in the middle of the queue can leave the queue. So you have to rip one element out in the middle of the queue. So this is an advanced requirement. You need not to be able to solve that one to pass the next test. But if you want to have a really good grade, you should definitely try this extra requirement, because things like that happen, that you have to implement things like that. So please take a look at this exercise, try to solve it, read the specification. And I'm aware that for many of you, this will be pretty hard. Thinking in these abstract concepts like references and queues and so on, it isn't a trivial thing to do. Granted, I fully understand that. And therefore, I gave you immediately a sample solution. You see it here. You have the sample solution for the basic, and you have the sample solutions for the advanced scenarios. So, happy coding! I'm looking forward to hearing your questions, and I'm looking forward to meeting you in class and hearing about your coding experiences. See you next time!